Hello, welcome to Software Performance Analysis on Intel Xeon Phi with Tau, a quick start guide. The first thing to do is to download the tar packages. These three packages here, the display on the right shows you where to download these three packages. This is the tar pack, the Tau package, the PD toolkit, and some extra utilities which we utilize. The first step I'll use is to extract the files from the Tau file in my base directory here. And as soon as that is done, I'm going to move these other tar files into that directory which is created. When I extract these, this creates a tau-2.25 directory, and I want to have all my tools associated with tau inside that same directory, so I put them in that location. You may put the PD tools elsewhere and just format the build where they are. Now I'm going to extract all the files at once, so I don't have to do this later. After these are extracted, the first step is to build the PD tool base. So when I extracted the tools there, it put things into a folder, PD toolkit, and I'm going to go to this PD toolkit. And this is the first item I'm going to build. So to begin this, I begin by typing in configure. And this begins the process of setting up the PD toolkit. This will run for a few minutes, and when that's completed, we'll resume with the next step. Okay, the configure finished. Now run make and make install, and I need to add this to my path. I'm going to add it now, so while I have the reminder here, so don't forget it later. Okay, this is exported to my path, so now I enter make, and following this I'll enter make install, and the PD tools installation will be complete, and then I'll move on to the next step of setting up Tau. Make completed, so now we type make install, and this is done. So now I go back down to the Tau directory, and this is the key point, is how I set up Tau. And it's important to get this done correctly on it. So let's start with this configuration. There are several parameters which I need to add in here to set this up. We need to get the representations correctly. So we're using the Intel Xeon Phi. With Intel Xeon Phi, we want to use the Intel compilers. So I set the C++ compiler to be MPI ICPC. I set the C compiler to be MPI ICC, and the Fortran compiler to MPI iFort. These are the configurations of work. Specifying minus MPI means that we want to instrument MPI programs. We're going to point to the location that several utilities will use, and we'll fill this in here. These are actually downloaded, but it will recognize that they're downloaded and that we want to use them. And it's also very important to specify the architecture equal Mike Linux. And so this will build Tau configuration to target the Intel Xeon Phi. And I give it the directory for PDT. The program database tools, which we just installed, if you put them someplace different, just provide that path. And the configure is ready. So let's configure, and then when this configuration is done, I'll again export the path. Okay, when the configure ends, now again I'll add the Tau Mike Linux bin directory to my path. And then I complete by typing make install. Okay, after the make install is complete, there's something to do before I start using it, and that is to set up my makefile. So I will set up the environment setting, tau makefile, to point to the makefile we created in the lib directory. And there's a makefile here created. It's marked makefile.tau, ICPC Intel compiler. It's configured for MPI and uses the PD tools. So now the tau is configured and I set my makefile, I'm ready to start doing one of the examples. I'm going to use an example that's included in the tau package. So I just go to the examples directories inside tau directory, and there's a directory called which is a matrix multiply, and there's a makefile here. This makefile will pick up the makefile environment setting just set, tau makefile, and it will include the tau makefile here and use those settings. So we can build it, and I can now use that to build. And you can use this makefile as for guiding you on how to make modifications to your makefile to work with it. If you don't use a makefile, that's not a problem. I can just use the scripts included with it that we set up, tau ccsh, and I give it the input matmult.c and matmult initialize.c, and give it a name -o, command line build a.out. And either way, I get an instrumented binary, which will give me profile hotspot data from running on the Intel Xeon Phi. I'm now ready to instrument. Things are set. I now need to set up some environment settings which are necessary to run my MPI code on the Intel Xeon Phi. And this has nothing to do with tau. This has to do with environment settings I need to run MPI on the Intel Xeon Phi. So I need to set up the MPI mic setting enable. Very important. I need to set the environment setting for MPI root. This will tell where to find the PMI to start up MPI run. And I needed to add the load library path, enhance that. So last I set the load library path, and my environment is set up so that my disk, my home disk, is NFS mounted onto Xeon Phi, so I don't need to copy over the MPI libraries or my binary executable. I just set the environments for it. If you don't have a disk cross-mounted, you may need to copy over the MPI runtime libraries, the PMI library, as well as your library as well. So follow your settings for your system. And now we're ready to run. I'm going to create an MPI host file. And right now I'm just going to put in it mic 0. I'm just going to run on the mic card on this system. In the next example, I will run MPI ranks on the host and the Xeon Phi and collect profile data, performance analysis data for both, but this example is just for the Xeon Phi. So we're going to just use the Xeon Phi file here. I'm just going to run 4 MPI processes, and I'll give it the full path to my executable. Okay, so I've started to run. My MPI job is now running on Intel Xeon Phi card, and in a couple of minutes I'll get the messages that when it completes. And we'll just wait a second for that. Okay, my MPI job completed on Intel Xeon Phi, and if I look at my directory now, I'll see that there are now these new profile files, profiles 0, 1, 2, 3, and 4. This is the analysis data we collected, and now we can view that and see the performance analysis data. To do that, we'll run the paraprof. So I just type paraprof, and it will automatically take the profile files in my current directory, and it will open up the display on this data. So let me step back a little bit so I can capture some more items here. Okay, let me resize this window so we can see things better. And so here's my paraprof data. It shows me I have the 4 MPI processes which ran. It shows me the top functions time was spent in for each of these. It shows me the minimum for each of them across all the ranks, the maximum, the average, and the standard deviation. All 4 MPI processes are running the same workload and the same work, so there's very little there. I can dwell in on this though and choose to look at this by thread, and it will let me jump in and look at the hotspots within a single function. When I choose thread, it'll let me choose which rank I want to look at. I'll just take MPI rank 1. I select this, and then it will give me a bar chart, and this bar chart shows me where my time is spent in function compute and compute interchange. I have some time in MPI finalize, MPI init, and allocation, memory allocation as such. So this is just a basic hotspot profile. And the next video will show how to do the profiling with both Xeon and Xeon Phi and do a heterogeneous run. And then the next video, I'll talk about different metrics we can capture. We can do more than just the hotspot profile. This is a quick start guide to get you going. Please watch all 3 videos to get the full range of the power you can do with Tau on the Intel Xeon Phi in doing software analysis.